Okay, good afternoon, everybody. Thanks for joining us this afternoon to the second QEP showcase. We're going to be focusing on today on the QuantWays, which is basically the redesign of our Math 1102 course, which is Introduction to Mathematical Thinking. I'm just going to provide the welcome remark and then hand it over to our QEP director, Dr. Evan Wantland, and he's going to go over the details with our faculty. Dr. Sarah Birdsong also joining after that, but no worries, I'm going to be here, and also if you have any questions later on, I'm going to come back in and we can answer any questions you may have. So without further ado, I'm going to just hand it over to, I'm TK, the chair of the math department. I hope I said that already. I'm going to hand it over to Dr. Evan Wantland, the QEP director. Evan.
Hi, everybody, and thank you for coming. My name is Evan Wantland. I'm the director of Math Pathways here at Charlotte, and I would like to talk to you about our QuantWays project. And our QuantWays is our course, which is meant for non-STEM majors in our general education. So I'm going to start here with a word cloud. This is something I get on the first day of class from my students this semester when I ask the students in this class, when they think about math, what do they think about? And so this is our day one responses from the students in this class. And what you'll notice is there's not a lot of words like fun and yay and can't wait and things like this. So this is sometimes students that might be hesitant to be in a math class, but it's not necessarily bad students. It's students that maybe just have not chosen a major or field which is math heavy, but they certainly are qualified to be good students. So this is the sort of the before, right? This is when they start before. Okay, but I want to give you a bit of a snapshot of how this fits into the much larger, oh, the slide did not progress. Oh, there it goes. Sorry. There's my word cloud. So here's my word cloud of what people, like the student said, like I said, the first day of class, and boo is across over there, sadness, devil, right? So, there's a couple of good words in there, but this is pretty much the typical responses you see from students early on in the semester in this course. Most students are in this course because they need to fulfill math in their general education. They need the quant the quant requirement, and so this is who we see in this course. Now, once again, this is part of a much larger project, our Math Pathways project, and so let me give you a little background on this. So this is really based on a lot of work done out of the Dana Center at UT Austin, which looked at national trends and what was happening in gateway math courses. And these are the things we see around the country, and we see not great passing rates in these courses. You might have heard the 50% number bandied about for college algebra nationwide as a success rate. So not necessarily a good success in these gateway math courses. Maybe these courses were not as relevant to students as they're going through their degrees. And there's plenty of evidence to show that these can be stumbling blocks for the students as they're trying to progress toward their degree. So what we did here is we looked at the results from the Dana Center and we asked ourselves, what is it we can do here at Charlotte? And what is happening here at Charlotte with respect to these challenges? And what can we do for our students and what we can do for our programs to make these courses relevant, to take away these obstacles and to get these success rates up in these courses, right? So once again, this is something we looked at for us, for our students, and what does it look like? And eventually this became our QEP, our Quality Enhancement Plan, Math Pathways, so branded NINERways. If you're not familiar with this was part of our SACS reaffirmation of accreditation project. They were here last March where we presented our plan to them and our entire reaccreditation folder, and the visit went very well. We got some great feedback from them, and we are moving forward with this project. And you'll notice this, officially this project is 2023 to 2033, and I'm already talking about a showcase of a redesign of a course that sort of happened before this. And in fact, this isn't even the first course that we've redesigned that's sort of been part of this QEP. This is based on our StatWays pilot project. and sort of gave us the model for the entire QEP moving forward. So I just want you to notice that even though the QEP is officially beginning now, we've got our baseline data from last year, that of course the ball has been rolling in mathematics and we've been doing things for a while. Once again, a major focus of this program is student success, right? We're really looking at what we can do to improve our student success, our students, our Charlotte students. How can we improve student success in our general education program, our new general education? And a big part of that is redesigning these courses, redesigning these. Right, so this built us into the pillars of the NINERS Way project. And like I said, a lot of this was built upon our StatWays project. This is sort of a lot of the process that we went through as we redesigned our stats for the social sciences. If you're interested in that, we've done a similar showcase and the video is available. But the main pillars here, you see they align with what we saw in the Dana Center's report. We want to provide relevant structure and alignment to these math pathways for the students as they're coming through for their program and their career. We're really interested in building a community of practice among our instructors. We want close coordination. We have lots and lots of sections all over the board, and we really would like to see these to be more uniform and more conversations among the instructors for the course, sort of tearing down these silos between the instructors. And of course, any of the changes we're going to make, we're going to really rely on evidence. We're going to look at what has worked elsewhere, what does the research show, the kind of pedagogies that can help us. And as we redesign these courses, redesigning them from the ground up, instead of retrofitting maybe some new techniques in there, thinking about redesigning a course fully on a student-centered and a student success design. Now, this led us to our three math pathways. We, of course, have our massive algebra to calculus pathway. So this is where we're seeing the bulk of our STEM majors, engineering, things like that. That's our college algebra, pre-calculus, and a couple different flavors of calculus in there. We have our StatWays project. This is another one of our recently redesigned pathways where we've had the old Stat 1222 and we've built a new course Stat 1322. Once again, there's a whole nother showcase on this. And today what we're talking about is our QuantWays path. And our QuantWays path is sort of an island. It's sort of a course that sits alone by itself. And this is our Math 1102 course. And this course is, once again, is designed for our non-STEM major students who don't otherwise have a math requirement within their program, within their major. It's not required of any program. It's not a prerequisite for any course. However, it does satisfy general education and mathematics, and it has a really important place in our curriculum. And that's what we're going to talk about today. Now, the whole project, we have big goals for this project. So for the entire NINERways, for the entire Math Pathways project, we would like to see big improvements in our success rate in all of these general education courses. We're looking to not only reduce the DFW rates we see, but we also want some sort of independence between our sections. We don't want to see a wide variation in our sections of the rates that students are successfully getting through those sections. And course coordination is one of the ways we're hitting that. But also with that, I always bring this up as well, as we're looking to improve these DFW rates, we also have to really understand what it means to get a C in these courses. And what does it mean for a C? How does a C translate to future courses and things like that? And that's something else we really need to look at. But very high on our list is reducing the equity gaps we see in certain populations. So the main populations we're looking at is minoritized students. We're looking at the gaps we see for our Pell eligible students. And we're also looking at the gap we see for transfer students versus the students we get that are first time in college. We see a really big success gap there between our transfer students and our first time in college. And once again, this is one of the things that's extremely important to us, because we see a lot of transfer students. So this is a very important thing to UNC Charlotte that may be a bit unique to us compared to other institutions. And of course, our overall goal is to increase our efficiency toward graduation. That is, by removing these barriers to students taking these courses and progressing toward their degree, hopefully getting them through their degree in a more efficient, expedited way. And this also fits very well with the state's new funding system, where instead of just looking at how many students we have in seats, they're also looking at other metrics like efficiency toward graduation. So this is good timing for us because we actually do pretty well on those metrics. All right, so what is this course we're talking about? Let's take a look at it. It's our Introduction to Mathematical Thinking. This is a refined course description. It's not a big difference from what we said we were doing before, but perhaps the most important thing to notice here is there are no prerequisites to this course anymore. We used to have college algebra as a prerequisite for pretty much any other course in our program, but one of the discussions was to remove college algebra as a prerequisite of this course because there's plenty of great things you can do in this course that do not require college algebra. So as we're talking about this redesign, one of the important things to realize is we were trying to design this so that it was not algebra heavy. Typically, students have had algebra before they get in this class. They maybe have had 2 courses in algebra before this class, and it could very well be that algebra didn't resonate with them, and that's maybe why they chose a major which was not STEM-based. But for whatever reason, we don't feel like it's a great idea to rely on algebra, and we don't feel that's necessary to do quality mathematics at the collegiate level. Other thing you might notice here, it says things like topics are drawn from, and one of the points of that is this course is not so heavily dictated on what we must accomplish in the course where it comes to material, because this is not pre-calculus, which has a calculus course following it up. This is a standalone course, so there is some flexibility in the topics you teach, and we feel this is a strength of the course because the instructors can they can design the course with their specialties in mind, and they can add the topics that they're passionate about. For example, you see graph theory in here, and I'm a graph theorist, so I like to teach a unit on graph theory every time I teach this course, and that makes it more fulfilling for me as well. All right, now, how did this all begin? Well, this all began a couple of years ago when our undergraduate advisor, Kim Harris, contacted me and said, Evan, would you like to redesign our Math 1102 course? And I said, sure, I'd love to. And she said, okay, do it. So I did, and I started this course redesign and started through this process, but this didn't happen in a vacuum. So Sarah and I and many people in the math department have gone through a lot of professional development over the last few years, preparing us for course redesigns. The STEM Teaching and Learning Academy is absolutely fantastic. I've been in that for several years. The Active Learning Academy on campus, I was a member of that, and learning how to use active learning techniques and getting to work with faculty in other programs. I got to work with faculty from the College of Health and Human Services there. The Student Experience Project, looking at things like growth mindset and belonging for your students. That's been an important program for us as well. Numerous CTL workshops, I've been to tons of those. And there was a broad base of professional development that we had already had. So yeah, this was sort of an organic course redesign, but at the same time, I was a lot different redesigning this course after all of this stuff than I was before. Now, finally, one of the important last pieces to this was the Career Competency Institute run through our Career Center. Because one of the things we said is we want to make these courses relevant to students in their majors. And how do you make a course relevant to students in their majors if it's required of no majors and it's a prerequisite to nothing? So there's no guarantee that a student from English actually takes this course. They could take other math courses. They could take a logic course. They could take a programming course. So how do you make it relevant? And the answer is your stakeholders you attach to is the Career Center, and you can talk about career competencies in your course and attach it to this. So when we're talking about these career competencies, this became sort of a big part of what we were doing in the course. And that is focusing on things like communication, critical thinking, leadership. You can see them here. And a big emphasis of the Career Competency Institute is you don't need to change your course to emphasize career competencies. You just need to you want to make sure that you tell your students what you're doing, being intentional about what you're doing in your class. And I talk about, for my students, nobody at a job interview will ask them, can you convert this Mayan numeral to a Babylonian numeral? But they might ask them, can you think of a time where you took a leadership role in a group in maybe a course outside of your major? So we don't have to actually build new things to emphasize these career competencies. The way we're building our course, we just have to emphasize these things. So This has been sort of a nice thing as our redesign to trying to make the course relevant, and it gives us a context to talk about this course. Right now, I certainly did not do this alone. I started off as the course coordinator for this course, and then I became the Math Pathways director, and Sarah Birdsong took over as the coordinator of our Quantways Path and has been instrumental in the redesign from there. And also Arndam Roy has also been in our team and has been working with this as well. He's been in the STEM Academy, and that's been great as well. And now I am going to pass this off to Sarah and have her go through a few more of the details of actually what we did in this course and this redesign. Sarah, take it away.
One of the things that you probably picked up from what Evan just said, one of the things that we were really focusing on when we were redesigning this course is what the students were going to be experiencing in the actual class. Just to be very explicit here, we wanted that to be a positive experience. So we said, all right, well, how are we going to get there? And we started brainstorming some of the things that we wanted to do specifically for the students, as well as what we wanted to do in the classroom each day. And then we're like, wait a second, we need to back up. What can we do with the faculty to make sure that regardless of who's teaching it, say in 5 years down the road, we have to have somebody come in and they've never taught before, how are we still going to get some of these same outcomes in their section of the course? So we also looked at that, we backed up and we looked at what are we going to do here on this sort of, I don't want to say administrative, but on the faculty side. The first thing that we decided to do was that coordinated sections. This is really tying into what's going on with the rest of the QEP courses as well. For us, that meant making sure we had the same textbook across all sections, which hadn't been done before. We wanted to make sure that all of our courses were doing group work in the classroom. We are working through building out a bunch of different assignments, some of them in-class assignments, a lot of them out-of-class individual assignments, where the students are reflecting on what's going on with the math and specifically at how it ties to their life. How does it tie to them personally? How about for their future job? What about with their major? These sort of things. We didn't want our future faculty to have to worry about building all of this up from the groundwork. So we are currently, just from a logistical standpoint, building out a Canvas template course so that they can copy that over and use already tested out assignments in their future work. The other two really big things that we got for this course is, one, we got all sections this semester and all but one section last semester assigned to active learning classrooms. So we're hoping to have that going forward. And we also have had student workers in the classroom helping with the implementation of group work. This year we're using PALs. Last semester we used preceptors, and we're in the process of deciding which one is better for future. This here is pictures of students actually working in the class. This is our new, as of last semester, active learning classroom in Fretwell. We're super excited about this room, although we have been in other active learning classrooms as well that work amazingly across campus. You could probably get us to do a whole hour-long shop on how awesome active learning classrooms are, but I will strategically move on so I won't geek out on you guys. The next thing is just to give you guys some context of what the course looks like. So this is from a topic standpoint. We decided to have 4 topics across the semester. The topic 1 and topic 4 are common to all sections. We really thought problem solving was the sort of main core focus of this course, and it'll trickle down through all of the other topics as well. And then also the last topic of voting and apportionment, really tying in the math to something that they're going to see in their day-to-day lives going forward. The middle 2 topics, these are where the individual instructor of the section will get to pick some. So far, we've fleshed out 5 topic modules. To be fair, they are in progress. I wouldn't say any of them except for problem solving is all 100% done yet, but they definitely have their outlines and are getting there. We also currently are in the process of talking about what happens if we get an instructor down the road and they look at all of the topics that are fleshed out so far and say, you know what, I don't like any of these. I want to propose a new topic. What would they need to have in that new topic design to really meet the goals of this course? What are those key components, some notes and some homework questions? What are some of those extra supplementary things that need to be fleshed out? So we're figuring that out. We'll hopefully have that done soon. The next thing to talk about is then flipping over to what the students see. So some of this we've already talked about. We've put our students into group, and we do group work depending on which section you're in, daily, almost daily, or weekly. The students work with each other, all sorts of different activities. And they also have this whole, if you will, a whole ecosystem that they're in. They're working together as groups, but they're also then applying that content, not just in class where they're exploring what's going on, but then when they come out of class, where's that content, those topics going further? Where are they going further in their lives? How do you apply it then to homework? We've got discussion boards that we've implemented where they share with their classmates where they're seeing these connections to the math topics to their different lives. We've also made the choice to de-emphasize test. If you remember that word cloud from the beginning of today, and a lot of it was very negative, to put it lightly. Stereotypically, these students have a tendency to be a bit scared or not happy about having math tests. So we really wanted to make the course where they could shine and show that they understood and knew the material without poking those really scary spots for them. And also they are working with our in-class student assistants as well. To break it down in terms of how we decided to break all this stuff up, you'll notice down, and I'll work bottom to top here. On the bottom, we actually broke our final exam up into two parts. One is still sort of a classic written final exam, and then we split out a fair amount of the percentage points of that into a final group project. More on that in a second. We also lowered the percentage of what the mid-semester exams would be and took those lower percentages that we took from the test and put them into the in-class work, and also some of those out-of-class assignments where they have extra practice with material or extra time to relate to the material. Just as a shout out to groups, because this is such an integral part of this particular class. There's lots of different ways that you can form student groups, but what we have found works really well for us is, first of all, make sure that the instructor forms the groups themselves. One of the things that I read in the paper, I'm now wishing I had looked up the title so I could tell you guys. One of the things I read in the paper, they said psychologically, you should tell your students they're working in teams. It really focuses them to how they would work together in groups outside of the academic life. So that's one of the things that we've done, to sort of focusing their attention to further on in the future of where they would use this. We also are putting them in consistent groups throughout the semester. So that day one, go find your different teammates to get together, icebreakers, introduce yourself, etc. If there's issues, of course, we'll deal with that. But so far, based on how we've put together our groups, there have been very, very few issues of needing to shuffle people around to get new groups in the middle of the semester. For this particular course, one of the things that we found in forming the groups, if you don't do random groups, if you're actually choosing the groups, is you can almost select them based off of their major as one of the key factors for putting them in groups, and it works very, very well. That won't work in all courses. For example, one of my other courses that has only 2 majors in it, that would not work. The next thing that we did, while we are de-emphasizing tests, we also did an extra thing for the test, because we didn't get rid of them, we just made their percentages smaller, is we wanted to give extra support to our students for these tests. We really wanted to have a lot of transparency in what our test questions are going to be, so that these students didn't have any surprises going into the test. They can have a little bit of confidence, hopefully a lot of confidence, going into the test to take them. One of the things that we've done to do that is, in terms of the process before we get to the test, is we start off and we have the students work together in their teams to build a study plan. This comprises of a couple of things. The first one being, what do you think the core topics and the main topics are? Also, them actually writing sample questions they think are very representative of the topic we've gone over, and looking over them. Some of them are really amazing questions. Then we go and we talk about what they've come up with, and we go through a full list of topics, sort of like what I would consider a classic study guide, where all the list of topics and definitions they need to know are typed up. We also have, before the test, in class, and it's presented slightly different in the different sections, but what's similar to most of the sections is we've been implementing some sample questions that are written in the same format as test questions as an in-class quiz. So they do it on their own. It's in that same sort of test-taking situation. And then we talk about it. Then they talk with their teammates about it, come to a consensus of what was going on. And we talk about, well, what happened? What wording was confusing? What does this really mean here? What should you have been looking for in this question? And then we also have supplemental resources over on Canvas, online questions where the students can work through it with extra practice at their own pace and at various times of the day. But our goal here really is on getting them to think logically and problem solving. So we're not super focused on them remembering a formula. And to that end, we've actually been putting reference sheets attached to the end of test that give the formulas and the key definitions that they need. That way, the focus here is on them using and applying the knowledge, as opposed to just memorizing a bunch of facts. Because, let's face it, a lot of these students may never need to remember any of the specific math facts, but they do need to know how to take a formula or a definition or something that's in their life in the future and apply it somewhere. And that's at least our goal with this.
Hello everyone, welcome to the Grade 6 News. My name is Noam.
And my name is Johnny. Today we will be talking about the difference between inductive and deductive reasoning.
You might be asking yourself, what exactly are inductive and deductive reasoning? Well, don't you worry, because we have Ojanukwa and Danielle to help explain it to you.
Take it away, guys.
Hello everyone, my name is Danielle Klein and I'm here to talk to you about inductive reasoning.
Hi everyone, I'm Ojanukwa Kadiri and I'm talking about deductive reasoning.
So what you just saw there was an example of one of our final projects from last semester. So as you saw, it was a bit creative. And one of the things that we've done for this, just to give you a little bit of background on the structure of how we've set up this project, is we've told them to make 3 to 5 minute long videos. Each one of the teams in the course has a different topic. And we've built this currently that they are building resources for their classmates for studying for the final exam. But as you saw, this format actually allows for a lot of flexibility, creativity. If there is any sort of anxiety in terms of presentation, this does seem to help with that. And one of the things that we've really noticed and are very much hoping for is that it allows them to structure their workload so that they really have built up the strengths of their team members. Now, we very much discuss the pros and cons of group work versus individual projects. And so we've put in a number of different things to mitigate if there did end up being any problems when the teams were working together. One of the big things is we've got a bunch of preliminary assignments attached to this project. It's not just a one and done type thing. We've got the topic selection, we've got outlines, we've got drafts, we've got them putting their slides in, that whole thing. And we added in an assignment at the end, which we've been calling a project debrief, which is an individual assignment. And it really asks them basically what happened, who did what work, how did it go? And that's hopefully they don't wait till then, but that's definitely a place for them to be able to point out, were there any issues that we need to worry about in terms of how the teams were acting or interacting, or maybe I should say ghosting their teammates. But we really wanted this to be a positive experience, so we wanted to address both of those situations. We've collected some feedback from this semester and last semester. A lot of these quotes that you see up here are from this semester, but also some from last semester. And notice they do have a bit of a different feel from that word cloud at the beginning. So we are hopeful that at least some of these changes we've been making are for the best. You'll notice they're getting more excited about what's going on. One of the things that we did last semester was our largest section was 70 students. Our smallest one was around 40, so we had different sizes. This semester, our sections are 90-person sections and 170-person section, so they're larger. And what we're getting is the same sort of feedback. You'll notice the middle comment on the second column there. This is from a student who's in one of our 90-person sections, and they don't even notice it in terms of how the course is structured. I did want to end this slide on top, pointing out the quote there on the second column at the bottom. This is a student from last semester, and they said that this was actually their first math class where they weren't scared to come into the classroom. So we are very happy about that. And then she actually gave a wrap up there in terms of how she did in the course by the end, and that this was actually her first math course where she ever received an A as her final grade. So we are hopeful that that is not an isolated incident situation.
All right, thanks a lot, Sarah. And I can't say enough about how it's how fun it is. I've always enjoyed this course. Courses like this have been around since the late 80s, early 90s. And I've always enjoyed it. I've always enjoyed the liberal arts majors. This is often called math for liberal arts in different places. And yeah, the group work, it does work very well with these students, allowing them alternatives. They embrace these alternatives that we allow them. My class today was doing a project that actually Sarah designed and showed me last week, which I did. And they really take to it very, very quickly. They had to combine, I call them pods, Sarah calls them teams. They combined and did these things. And it really is nice, and giving them this kind of attention, it's well worth it, because it comes right back at you, and you see these positive responses from the students. All right, so where are we going forward? Well, like I say, this is a fully coordinated course, and we are really trying to build it so that it is transferable, and it's gone pretty quickly. We're looking at putting graduate students into this course next semester. In fact, Sarah will be teaching this course with 2 new instructors next semester in our 3 sections. And that to me is really big, because now we've already got this course where we've built it up, we've added these new things to it, yet it is portable enough to be able to bring in new people on the fly and get them doing this. We certainly want to increase and emphasize the metacognition techniques we're doing there, doing a lot of reflection. You know, were you a good team member today? Did you listen well? Did you communicate well? Did you take on a leadership role? Things like that and pull everywhere. These are great. We'd like to formalize these and be better at these. We'd like to get better at using our student assistants in class. As Sarah mentioned, we've had preceptors, we've had pals, and we would like to figure out what is the best model and how best to train these student assistants in there. And then one thing you might have noticed is that we sort of emphasize the career competencies early on, but we don't have a good culminating project for that yet. But that's something we're working on now, where the Career Center offers us a way where we can write fake interview questions or have the students do a reflection on the career competencies they've learned in the course. I was at a conference last week, so I invited the Career Center to bring one of their people over to my class to talk about career competencies in class and do an activity there. And we do know that we would like a better culminating project for these competencies. Also, as Sarah says, the fully packaged content and figuring out how exactly we want to put these modules into our course is something we'd like to finalize. We've been sort of depending on textbook modules, but what does it look like if a professor wants to do this and they want to do a module on fractals, or they want to do a module on cryptography? And these are things that fit well within a course like this. It's just a matter of deciding, how do we want to build it? What are the common activities we're going to do? Can we put it in a good package, and can we get it fulfilling the rest of the philosophy of the course? And I think in the future, right now, we're asking our students to do projects based on things they've seen. Now, I asked my students, in a few of my topics, I asked my students to do a little bit more that maybe in the book are available than what I did in class. But for the most part, we've really been asking them to sort of build, review videos for the final. Well, as we do this over and over and over again, we should get some sort of repository of these videos. And also, I think that this will allow us the ability in the future to start saying, all right, let's take the subjects we did and push it just a little further. Let's do something related to that. And I think from now, we're okay with just managing them doing the videos like this. It's new to all of us, so there's no reason to try to do everything at once. But I do think that we have aspirations to make these video projects more relevant and see what they can do, quite frankly, because I think that if we allow them the creativity to do new things, they will step up and they will do it. And these are really important for us moving forward as well. There's a lot of exciting things with this. So really, that's about where we are right now in this project. And once again, I want to mention, I'm really happy that you all could make it here. And what we're looking back for here is any kind of feedback, any kind of questions. How would you see yourself collaborating with math to do this sort of thing? Are there career competencies that you would like to see? Are you doing that sort of thing in your class? How can we steal what you're doing in your classes? Is this kind of redesign, this kind of collaboration among faculty something that's common to you, or anything like that? Anything at all, and it certainly doesn't have to be just here today during this webinar. It can be any time when this is a project that will be going on for a long time. So that's about all we had. Has anybody got any questions? They can put them into the comments there. We're monitoring the comments, or you're certainly welcome to just speak up if you like. Raise a hand. I can't see the participant, but I'm sure there's someone. Anything?
Not seeing any questions in the chat right now, Evan. If anyone has any questions and just wants to unmute, that's fine. Oh, we do have a question that's come in. Okay, Bernadette would like to know, where do the students make the videos?
Well, they make them on their own. We do give them time in class to work on them. But they make them on their own. They use what's the one thing they were excited to use? Canva. So many of them were talking about using Canva. Some of them, it's new. They're learning from the other students. Some students have experience with YouTube channels and putting up videos on YouTube. They're learning the experience. Just this morning in my class, one of my pods, literally the conversation they were having was between the two people that had a lot of experience making videos and the two that were just like, I want to learn how to make videos. So that's what's going on with these. And I tell them, look, they're going to be better at it than me. So
what is the timeline for the test support? For example, how long before the exams do they start with test support is another question we've received.
Well, of course, it could be different for every instructor, but I would sort of say we do this in modules, and the test support really starts to happen pretty early in the module. Because even after you've just done one topic, you can do poll everywhere questions, and you can ask them questions in class. What would you think would be a good question on the exam from this? Or what is something you'd expect to see from the exam? And this is really powerful as well, because when I gave my first exam this semester, I asked them after it, how many of you was this the first exam you ever took in college? And I had 45 students raise their hand. So, that was the very first test they ever took in college. This is important. And one of the things about this test support is I have this vision that every student who takes a math course at Charlotte, in that very first math course, they will see test wrappers, they will see exam wrappers, they will see some sort of reflective piece before the exam and some sort of reflective piece after their first exam to think about these exams in a different way. So I believe that each of us who's been involved with the project are interested in alternative assessments, interested in de-emphasizing exams, and we're just trying to figure that out.
We have another question that's come into the chat from Sherman. Are students opening up in class? Do you feel student engagement with their professor increases with this approach?
Well, I'm worried that there's a lot of math people in here, but I'd say 110%. Right. So that's the way I feel about it.
Sarah is saying yes to that too in the
Yeah.
chat.
Yeah. I mean, it's yes. You should come and see them. You should see them when they start to work. My class is 8:30 in the morning and they don't love it. And they hate that I'm so awake. But I had one of my non-traditional students today, a vet, tell me, this is my funnest class. I don't want to, he was like, I don't want to tell my group that, but this is my funnest class. Right. So
I just like to, I would like to add one more thing, which is if you have a chance to come to visit the classroom itself in Fretwell, I think you'll get a feeling of that, because it's designed as an active participation classroom. Their desk where students are gathering together and having that environment. And I imagine this is also an important part of the course.
I literally sat down at every one of the tables with every one of my pods this morning in my class to talk about where they were with their projects, where were they moving forward as the group was doing an activity together. So I just had to interrupt each one of them for a minute or two. And I got to look each one of them in the eye and talk to each one of them. And I've only got 75 students in my class, but still that's really good.
Okay, that's worth me coming off mute to say that's outstanding.
Great.
That is tremendous. Great, great.
Yeah, it is, and that's the class you want to teach, right?
Yes.
I mean, like I say, I love this class. I love these students, so it's easy for me. I want to address Bernadette's question. Can I comment on the course grade distribution for this course? Okay, so this is pretty new, and we're just now putting it together. I would say that this semester has been the most robust, sort of coordinated with the people we've got in place. We, of course, did it last semester. The good news was in our preliminary data last semester was that among all of our math courses, this is the one where we saw the least variation among the sections when we were looking at success rates. And that's really the main thing we've been looking at here. So we did see uniform among our sections. And like I say, this is very coordinated. We're talking about exactly what we're doing and when. We do not give common exams. We do not give a common final. I share my exams with everybody. We're pretty good about sharing things. But I would say that we're seeing, once again, what I would say is that I think traditionally when people think about this class, especially when people think about this class in STEM, they think about these as, and maybe this is the wrong word, but bad students are bad at math. They're bad math students. But I have honor students in here, right? I have people that are applying for graduate school and fellowships and things like that. These aren't bad students. They just have not chosen a field in where math is an emphasis. And when you provide them with an outlet for their intelligence and their creativity, they step up.
And to add on to it, the department, we have we do collect the distribution for each of the sections and the grades. And certainly I don't have it handy right now to share with the group, but if somebody's interested, I certainly can, talk with them about it. I
exactly
think
the data we're looking at.
We collect the distribution for each course, by section, and also overall as a course as well. And we compare that, those statistics with the overall, the departmental averages and so on.
Does anyone else have any additional questions?
Well, like I said, we're not going anywhere. So we're here to answer your questions, and we'd be happy to continue this conversation. Sarah and I talk about it all the time. So, we'd be happy to hear further from you. We'd be happy to have people visit our classes. We're proud of this project. So.
Thank you, everyone, for sharing today.